Georgetown College Chemistry Department. Just like last year, I'm bringing some kits that you can pick up for free at the library to take home and do some chemistry experiments. This is to celebrate National Chemistry Week, which is always the week that contains Mole Day, October 23rd. You will receive in your kit a packet with lots of different instructions for the different activities, and also the magazine Celebrating Chemistry, which has some interesting articles and some experiments that you can do at home. I'm going to show you today how you can do the experiments so you can see what they look like, but they're really most fun if you try them at home. So you'll have in your kit a box that looks like this that has a variety of tools in it, plus some extra cups and bags and things that will help you to do the experiments. Our theme this year is fast or slow, chemistry makes it go. And so a lot of the experiments have to do with things that speed up chemical reactions, like heat or catalysts. A catalyst is a special chemical that does just that, speeds up a chemical reaction. And then some of the experiments are bonus and they're just in there for some fun. Because these experiments involve heat, there's hot water in many of them. So please make sure you have a grown-up that's helping you with this so that you don't get burned while you are doing the test between hot and cold reactions. This activity is called Slow the Glow, and it's found in the Celebrating Chemistry magazine in your kit. What you're going to do is pull out the glow sticks. You only need 3 of them, so I gave you an extra one just in case one of them doesn't work right or just to have a little bit of extra fun. And you're going to set the glow sticks to glowing. So if you've never used one of these before, you just kind of bend it, it'll crackle, and you kind of shake it a little bit to get everything sort of evened out. And then what we're going to do is see what happens when we change the temperature of the glow stick. So I've got some cups down in here. One has hot water, one is just room temperature air, and one has some ice cubes in it. And we're going to place the glow sticks in each of the cups. Turn that. And then where's the light switch? So what you should notice, if you can wipe away the fog, is that the stick in the ice, especially the portion that's under the cold water, is very dim, and the other 2 are brighter, and you may even notice that the hot water one is glowing even brighter still. So heat tends to speed up reactions. What you might think about is what would happen if we switched these around. Could we get this really glowing brightly one to slow down? So we could swap these 2. This one's not glowing very much, put it in the hot water. And if we give it a minute, then we'll see this one starts to dim a little bit. I can get the fog off of there. And this one is glowing much more brightly. So the chemical reaction only lasts for a certain amount of time. If you've had glow sticks before, you know that after a day or so they don't work as well. But if you want to keep your glow stick for a little bit longer, you could take your glow stick and put it in the freezer overnight, and you should have enough glow left to play with it for a second night. So that's our first experiment. And then I'm going to show you a bonus experiment that is also going to use this area. You have in your box both a Band-Aid and a little mint. Mints that have wintergreen in them have a property called triboluminescence. What happens is that when you apply pressure to this, it will spark with a color. And so you want to do this probably in a bathroom where you can turn out the light but have the light switch nearby, and looking in the mirror. And so I'm going to try and illustrate this just by breaking it, but it'll really work a lot better if you have all the lights out. The Band-Aid will do the same thing as you open the Band-Aid. So if you open a Band-Aid wrapper really quickly in the dark, it'll do the same thing. So I'm going to see if this will work. Maybe I'm not strong enough. Guess I'm not strong enough. All right, let's try this. Bang. Okay. Oops. This is not going to work. You really have to bite into it. So if you bite into it, it will spark. So you'll have to look in the mirror while you do this, or have a friend look at it. This experiment is called Chemistry Goes Pop. It is found in the Celebrating Chemistry magazine, so you can see the details there. Your kit includes a couple of packages of Pop Rocks. If you want to be able to do this experiment twice, just take one of the packages and divide it between the 2 cups rather than using the entire package for both cups. So what you can do is pour half of your Pop Rocks into one cup and half into the other. Make sure you have the same amount in each. You'll want to start with a dry cup. If you've ever had Pop Rocks before, you know that as soon as they hit your tongue, they start to fizz and pop, and it feels a little bit like when you're drinking soda. The next thing you're going to do is compare what happens when you add cold water or hot water to the Pop Rocks. So you can see this cup has ice in it. This cup is pretty hot water. It's not so hot that it's burning me, but it's pretty warm. And at the same time, we're going to add them both to the container. Now, I'm not going to add all of this, just enough to see what's going on. You may want to pay attention to what each cup sounds like. So I can tell with this cup, there's a lot of color from the solution, from the Pop Rocks coming into here, and not so much with this cup. I hear a lot more popping from this one over here. So this is an example of how hot water will make a reaction go faster than cold water. I can also see what happens when I stir each of the cups. And I'll notice more bubbles in this cup, and I'll also notice that the little candies seem to dissolve a lot faster. So eventually in both cups, the candies will dissolve and I won't be able to see the individual candies anymore. But that's going to happen first in my hot water cup. This experiment is called Heat on the Move, and you'll have to look for this paper for the directions. And it has 2 parts to it. So for the first part, we're just going to look at how the liquid in hot and cold water move. And the way that we're going to see how it moves is by putting in food coloring. So your kit contains 2 different colors, so you can see how those react, or how each of those behave. And you're just going to put a couple of drops in each cup. So I have a cup of cold water. You can see there's ice in here. You might want to take the ice out while you're doing this so that it doesn't get in the way of watching what's going on. And then I have a cup of hot water here. So I'll just put a couple of drops in this one and a couple of drops in this one. Right away, you can see that the color moves a lot faster through the hot water than it does through the cold water. So it's taking longer for it to get to the bottom of the cold water. And as we watch for several minutes, we'll be able to see that it mixes faster in the hot water than it does in the cold water. Another experiment you can try is use one color for the hot water and one for the cold water, and then slowly pour one on top of the other. You will notice that the color for the hot water will stay mostly on the top, and the color for the cold water will stay mostly on the bottom. The second part of this involves looking at bubbles. So you're going to take a plastic cup and put a little bit of water and some dish soap. So you'll need to get just a drop or two of dish soap from home and add a little bit of water, and that's how you're going to make just a little bubble solution. Then you're going to have a cup for hot water and a cup for cold water. So we'll fill these again. This is my hot water. Oops. And let me get my ice. And here's my cold water. Now I don't want to fill these too high. I'm going to use a funnel that I've made from using a soda bottle, just cutting off the top of the soda bottle. And I'm going to try and put a thin layer of the bubble solution on the bottom. So I'm going to stick this in here, kind of swish it around, and I should be able to see a layer of bubbles on there. And I'm first going to put this on top of the hot water. Now I don't want it too high because I want to be able to get a nice seal in there. If you look closely, you'll be able to see a bubble forming on the top of this bottle. And this is because when air gets hot, it expands. And so the air inside the funnel was expanding and pushing on the bubble. Now that bubble popped, so I'm going to get some more solution on here. And I'm going to see if the same thing happens with cold water. And you might think to yourself about, well, what should happen with the cold water? If the hot water expanded, what's going to happen here? So I'm going to set this in here for a few seconds. And what you should start to notice, it's probably hard to see on the camera, is that there's a little indentation in here, as if the bubble is being sucked inside of the funnel. And so that's because just like hot air will expand, cold air will contract. And so it's making that smaller in there. So those are some things that you can do to look at hot air and cold air, or hot water and cold water. Okay? For this experiment, we're going to make a rocket out of a film canister. You know, you might be too young to remember cameras that had film, but they used to put the film in canisters that would look like this. So we provided these for you since most people don't have film cameras anymore. Now, before you start the experiment, you're going to want to try putting the lid on and making sure you hear it click into place. And if you don't hear it or feel it click into place, maybe have a grown-up try and do this, because it's really important that it seals all the way. It won't work if you don't get it to seal all the way. All right, we're going to see whether we can get this reaction to go faster or slower, again, based on whether we have hot water or cold water. So you may have done something like this before. Now, in your kit, you have a packet that has 2 of these discs of Alka-Seltzer. You only need about 1/4 of a disc, and it's kind of hard to break it into equal-sized pieces, so I ended up with 5 pieces here. So I'm going to look at my pieces and pick pieces that look like they're pretty close to the same size, so I have a good comparison. So these 2 look pretty close to me. And I'm going to set the others aside. I can use the others for launching rockets again. Now this is a good experiment to wear goggles for if you have them. If you don't, as soon as you set the rocket down, you need to step back at least 12 feet so that you're not in danger of being hit in the face by the rocket. So what we're going to do is we're going to fill the film canister about halfway with water. And if you like, you can experiment with what happens if you use more than halfway, what happens if you use just a tiny bit, how that changes things. So this one on your right, on your left, is hot water, and the one on your right is just room temperature water. And then I'm going to drop both of these in at the same time and then close the lids, which is going to be tricky to do at once. Now it's most fun if you turn it upside down. And you could see that the hot water one popped right away. And that's because that reaction was moving super fast. But if I wait long enough, the one with the cold water will also pop. It just takes longer for it to build up enough of the fizzy gas to pop. In this experiment, we're going to slow things down a little bit. We're going to use glue. Now, glue doesn't move around real fast, but we're going to slow it down even more with cornstarch. So both glue and cornstarch have polymers in them. You can think of polymers as being long chains, and they're a little bit like spaghetti in that they can kind of slip around one another and move around. But we can get them to slow down if we can get them to link together. And so they kind of get tangled and can't move around. So the first thing we're going to do is we're going to make a bouncy ball. And we're going to use about a tablespoon of glue. So your kit will have a bottle of glue, and it will have a container of cornstarch, and it will have a little bottle that has borax in it. For this experiment, I'm going to use the bigger containers that I have here. So I've put about a tablespoon of glue in there, and if you want to make a different colored bouncy ball, feel free to use the food coloring to put that in there. And then I'm going to add about a tablespoon of cornstarch. So a 1-to-1 ratio. However much glue you use, that's how much cornstarch you're going to use. Okay. Once I have that in, I can use a spoon or wooden stick and just kind of mix it together. And if it looks like it's still really powdery here, so this looks just a bit too powdery to really do too much, I'm probably right at about the right amount of consistency there. And the reason for that is we're going to add that borax, which is going to be just a little more liquid. So I need just a 1/4 of a teaspoon. If you don't have a teaspoon to measure, just a tiny squirt from the bottle here. And I'm going to put that in there. And the borax is what links together the polymers. It causes them to glom onto one another and get all tangled. So now this looks even stickier. Okay? This is the messy part. So you're going to want to make sure that you have your sleeves rolled up and the counter free of other things. You're going to put this in your hand. And if it's too sticky, you're going to add just a little bit more cornstarch. That'll help with the stickiness. And you're just going to roll it into a ball. Now, I have found over the years that kids are much better about making these than I am. So I'm going to try and bounce this ball for you, but I am sure yours will work better than mine. Oh, that one didn't bounce. But I'm sure yours will bounce because I'm not as good at this as kids tend to be. Pick that up. And if it's not working just right, try squishing it a little bit more, rolling it a little bit more, really kneading those materials together. And if it gets too sticky, again, you can just add a little bit more cornstarch, and that'll help with the stickiness. And I'll try this one more time. And it's not bouncing too well, but a little bit better. Okay, so that's making your bouncy ball. The other thing that you can do with cornstarch, if you've ever played with cornstarch before, you probably made oobleck. So this is good to do in a plastic bag or in a cup that you can throw away. And that's because it can be very messy as well. And in this case, we're going to use just water and cornstarch. So we don't need the glue, we don't need the borax, just the cornstarch. And I'm going to start by putting in a tablespoon of water. And it's really helpful to have a friend nearby who can hold the bag for you so you don't make too much of a mess. So I'm just going to put that in there. And I'm not going to add all of the cornstarch at once. I'm going to eventually add a tablespoon, but I'm going to do it half a tablespoon at a time. So there's half a tablespoon. Oops, I can get that out of there. And I'm just going to mush it around with my fingers. And you can see the water moves pretty quickly. But we're going to slow it down with that cornstarch, because remember, those polymers in there are going to get all tangled up and they're going to slow things down. So once this is pretty well mixed, then I'm going to add another half of a tablespoon. And you may need even a little bit more than a full tablespoon. You're just going to check on the consistency after you mush it around. And again, if you want this to be a different color, feel free to, put in a couple of drops of purple or blue or whatever your favorite color is. So I'm still seeing some of this really super fast moving watery liquid, so I'm going to add just a little more cornstarch. And eventually it's going to get so that as I'm mushing it around, I can almost feel like a solid in here. And so on this side of the bag here, it's not as liquidy as it is on the other side of the bag. So what happens with this material, you can open up the bag and kind of poke it and pull it out, is that it sort of looks like it's a solid, but if I try and pull it out, it immediately turns liquid. I can push it together into a ball. I can form a nice little ball there, right? But as soon as I stop moving it, it becomes liquid. So this is what's called a non-Newtonian fluid, because it doesn't behave the way it's supposed to. So right now it looks kind of liquidy, but if I squeeze on it, it's a solid. So if you have more cornstarch at home, it's pretty cheap to get at the grocery store. You can make even more of this stuff and play with it. And that's your oobleck. When you are done with your oobleck, please do not put this down the kitchen sink or into any sink or drain, because the cornstarch will clog the drain. So even though it looks kind of liquidy, you need to put this into the trash can. One other bonus thing we've included in your kit is a Tootsie Roll Pop, and the reason for this is because since it's October, we're giving you the opportunity to make a little ghost. So all you need from home is just a tissue or a paper towel. You can cover up your lollipop and take a twist tie and just twist it around there, and if you like, take a marker and put a face on it, and you have your own ghost treat. This is an activity for some older kids, and you're going to be able to make a little paper jack-o'-lantern that you can put a light in. So this is what's called a paper circuit. You'll have a card which has the template for the circuit on it. You'll have a light bulb, and it's threaded through a button to just kind of hold it in place, and you'll have a battery. Okay, so where it says 3V, that's where your battery is going to end up going. All right, and then you will have some shiny tape. This actually is copper, and so copper conducts electricity, and you will use the copper to follow the lines from the circles, so it's going to end up looking like this, where you will take the copper down to the edge of the paper, and then and it should touch the battery underneath, so we should have that have the copper underneath the battery here. And then what you will do is put your light over the two strips of copper, and when you fold this on the dotted line, fold it over and touch the other side. Oh, this was one of the batteries that had the plastic on it. Let me do this one. When you touch the other side, you were working before. Why aren't you working now? There we go. It will light up. So you've made a circuit. So then the second part of this is you will have some orange paper, And you will have directions to make an origami ball out of the orange paper, and then you can take the open end and stick it on top. Oops. And then in a dark room you should be able to see that glow. And feel free to put your favorite jack-o'-lantern face on.